When you think of Asia, what comes to mind? For a lot of us, it's a continent of superlatives, right? The biggest, the most people, but it's also a place of just incredible contrasts. So today, we're going to dig into how one single landmass can hold so many completely different worlds. Just look at these two pictures. On one side, you've got the massive snow-covered taiga forests in Russia, a world that's pretty much frozen for a huge chunk of the year. And on the other, the sun-baked desert near Riyadh, Saudi Arabia, where just about nothing grows. Frozen forests and blistering deserts. So that's the big question, right? How is that even possible? How can one continent be home to environments that are so radically different? Well, the answer is a really fascinating story about geography, physics, and the mind-boggling scale of Asia itself. Okay, so let's get into it. To really get a handle on the incredible variety of life across Asia, we have to start with the powerful forces that shape its climate. This is the why behind the what. And it really all boils down to a few key things. We're going to look at four main drivers here. Its massive north to south stretch, just how far some parts are from the ocean, its towering mountain ranges, and the seasonal winds that basically act like the continent's own circulatory system. First up is latitude. Asia is just enormous, from top to bottom. It stretches from just south of the equator all the way up into the Arctic Circle. And what that means is that it passes through every single heat zone on the planet, from the hot, sticky tropics to the permanently frozen polar regions. Next, think about how wide it is. You see, oceans are kind of like giant temperature regulators. They soak up heat in the summer and release it in the winter, keeping things pretty stable. But deep in the heart of Asia, there are places over 3,000 kilometers from any ocean. This creates what's called a continental climate, and that means brutal temperature swings. And check this out. This is where you can really see it in the numbers. Let's compare two spots at the same latitude. Omsk, deep in central Russia, has a staggering 85 degrees Celsius temperature range between its hottest summer days and coldest winter nights. But then you look at the coastal island of Sakhalin. Its range is less than half that. And it gets more than double the rain. That, right there, is the power of the ocean. And then, of course, you've got the mountains. The Himalayas aren't just the roof of the world. They're a massive climate wall. They literally act as a barrier, stopping those cold Arctic winds from blasting down into India, which keeps it warm. And in the summer, they do the opposite, blocking the wet monsoon winds from getting to the Tibetan Plateau, which is why it stays so high and dry. Now, this brings us to one of Asia's most defining and, honestly, most vital climate features, the monsoons. These massive seasonal winds are basically the engine of life for billions of people. Okay, so here's how it works. In the summer, the huge Asian landmass heats up way faster than the oceans around it. All that hot air rises, creating a giant zone of low pressure. This thing acts like a massive vacuum cleaner, sucking in all the cool, wet air from the Indian and Pacific Oceans. That's the southwest monsoon, and it's what brings all that life-giving rain. But then winter comes, and the entire system just dramatically flips. The land cools down fast, becoming way colder than the oceans. This creates a powerful high-pressure system over Central Asia that shoves cold, dry air outwards. This is the northeast monsoon, bringing dry weather to some places and some bitterly cold winters to others. So where does all that moisture go? Well, a huge part of the story is something called orographic rainfall. As those wet summer winds from the ocean slam into a mountain range, they have nowhere to go but up. As the air rises, it gets colder, and colder air can't hold as much moisture, so it just dumps all its rain on the one side, the windward side. The other side, the leeward side, stays dry in what we call a rain shadow. All right, now that we've got the forces down, let's take a quick tour to see the incredible results. We're going to drop into three totally different zones to see how these climate factors create entirely separate worlds for plants and animals. First stop, the equatorial zone, right here in the lush green rainforests of Borneo. This is a world that's all about two things: constant heat and a whole lot of water. The climate here is incredibly predictable. It's hot, it's humid, every single day, all year long. This leads to something called convectional rainfall almost every afternoon. The intense sun heats up the wet ground, that hot, humid air rises, it cools, and then, boom, you get a massive downpour. And all that constant warmth and water means you get these dense, layered forests, tangled up with vines, where everything is fighting for a little bit of sunlight. And of course, the wildlife here is just as unique. You find amazing species like the Provisus monkey that lives its life up in the canopy, and then powerful predators like the Sumatran tiger, a master of hunting in that dense jungle. Life finds a way to fill every single niche. Okay, now for a complete 180. We're jumping from the soaking wet rainforest to the hot, dry deserts of the Arabian Peninsula. And believe me, the contrast could not be more intense. Life here is all about extremes. Sizzling summer heat can get over 50 degrees Celsius, but then at night it can get surprisingly cold. That's because with no clouds or humidity to act like a blanket, all the heat the ground soaked up during the day just radiates straight back out into space, and the temperature plummets. Any plant that wants to survive here has to be incredibly tough. And the animals, just as specialized. The Bactrian camel is just a masterpiece of evolution. Its humps are for storing fat, not water, which gives it energy. It's got long eyelashes to keep out sand, and that thick coat insulates it from both the crazy heat and the freezing cold. Okay, for our last stop on this whirlwind tour, we're heading way, way north to the huge, treeless plains of the Arctic tundra. This world is defined by one thing: cold. The winters are long, dark, and just brutally frigid. The ground itself, the permafrost, is frozen solid all year round. It's only for a short little summer that the very top layer thaws out, just enough to let a thin carpet of mosses, lichens, and some hardy grasses grow. And the animals that can live here, like the incredibly rare Amur leopard found in the forests nearby, are just built for survival. They have huge paws that act like snowshoes, and this amazingly thick, dense fur that keeps them alive in that life-threatening cold. So, we've gone from the rainforest to the desert to the tundra, and what we've seen is that these totally different worlds aren't just random. They're all deeply, intricately connected. This map really says it all, doesn't it? Every single colored band you see here is a direct result of the forces we've been talking about. The deep greens of the rainforest? That's because of the equator. The big tan splotches of the desert, that's about distance from the sea and mountain range shadows. And the pale colors up top, that's the extreme latitude. It's all one giant interconnected system, a perfect tapestry of climate and life. We've just seen this system of immense scale and complexity, a delicate balance of forces that took thousands and thousands of years to create these worlds, which really leaves us with one last, pretty important question to think about. How quickly can they be unmade?